We are continuing with applications of right triangle trigonometry, and we will visit a couple of problems in our notes. And after that, we will do a couple of problems in homework 3-2 for right triangle trigonometry of our Lumen course. So the first one is this one. A radio tower is located 350 feet from a building, and from a window in the building, a person, and this is my stick figure of a person here, determines that the angle of elevation to the top of the tower is 29 degrees and the angle of depression to the bottom of the tower is 20 degrees. So we want to talk a little bit about what is the angle of elevation and what is the angle of depression. It is not in your packet, so you have to know what that means. So an angle of elevation or an angle of depression is the angle you make with the horizontal. So if I can sketch kind of a horizontal line, then the angle of elevation is an angle going up from the horizon, and that to the top of the tower is 29 degrees. And the angle of depression is an angle going down from the horizon. And per the problem, the bottom of the tower is 20 degrees from the level where the person is looking at the tower. And what we do know is that the distance, the horizontal distance from the person to the tower is 350 feet. So not only is 350 feet on the ground, but it's also 350 feet on this horizon. We also assume that if this tower is to be standing up and not leaning, that tower is vertical. Therefore, the angle between the horizon and the tower will be 90 degrees, in which case we now have two right triangles. We have the right triangle person to horizon and elevation, let's say. So right triangle PHE, and then person to the horizon and the depression PHD that goes downwards. And the height of the tower will equal to EH plus HD. And the reason I want to use those pieces is because they are legs of right triangles, and I can use right triangle trigonometry. So for both the angles 29 and 20, the 350 feet is the adjacent, and the pieces, the two pieces of the tower are the opposite. Let's call it opposite 1 and the opposite also, opposite 2. So I'm going to use trigonometric functions that contain an angle, the adjacent, and the opposite. So I'm going to go in my packet, and that function will be the tangent that contains the angle, the opposite, and the adjacent. So the tangent of 29 degrees will equal to opposite 1 over adjacent, which is 350 feet. If I multiply by 350 feet, opposite 1, that's EH, will equal to 350 feet times the tangent of 29 degrees. That's in feet. For the other triangle, the tangent of the 20 degrees will be the opposite, which is opposite 2 now, because I am in the angle, in the triangle of depression, over the adjacent, which is also 350 feet. Therefore, the opposite 2, which is HD, will be 350 feet times the tangent of 20 degrees. And again, that is measured in feet. So the height of T will be the sum of those two. if the problem is asking you for the exact answer before you round, your answer here will be 350 plus times the tangent of 29 degrees plus 350 times the tangent of 20 degrees, right? That's in feet. And then you can plug that in your calculator and round to the nearest tenth of a foot. So again, make sure that your calculator is in degree mode. 350 tangent of 29, close the parenthesis, plus 350 tangent of 20, and close that parenthesis, and to the nearest tenth, 321.4 feet. Is the answer to the height of this tower. The next one is also a problem similar to question 13 of your homework 3.2. Find x correct to 2 decimal places. So again, I need to work with right triangles. So let's put some names. Let's call this A, B, C, and D. I have two right triangles. The one is the triangle ABC. And the other is the one that I haven't highlighted, ACD. And X is not a side in either of them, but X can be composed from X1, which is BC, and X2, which is CD. So X can be equal to X1 plus X2, and X1 and X2 are legs of right triangles. In the triangle ABC, B is the angle at 53, X1 is the adjacent, and for that triangle, I also know AC, which is the opposite. So the opposite of B is 88. Therefore, I can use a function that has the adjacent, the opposite, and the angle to find the adjacent. So again, I'm going to look in my formula packet. Tangent contains the opposite and the adjacent. And therefore, I'm going to use the tangent. So the tangent of B, which is 53 degrees, equals the opposite, 88, over the adjacent, which is x1. And to solve for x1, I'm going to multiply by x1. And I will divide by the tangent of 53. So x1 equals 88 divided by the tangent of 53. Now in the triangle ACD, the x2 is the adjacent of the angle D, and the opposite is 88. And I will do the same calculation with the tangent function to solve for the adjacent. So the tangent of 36 degrees will be the opposite, 88, over the adjacent x2, and I will multiply by x2. And then I will divide by the tangent of 36. So x2 will be 88 divided by the tangent of 36 degrees. Now, if the problem is asking me for the exact answer, I'm gonna take this equation and I'm gonna substitute the exact answers for x1 and x2. I'm gonna say that x is equal to 88 divided by the tangent of 53 plus 88 divided by the tangent of 36 degrees. And this is the exact answer. If they are asking me to round to the nearest tenth, let's say, then I will plug that into my calculator to find the answer. 88 divided by the tangent of 53 plus 88 divided by the tangent of 36. The answer is 187.4 approximately. Now, we will not follow the notes after this. We will go to solve a couple of problems from our homework. So let me put some lines so that I can know where to write. So question 14 is to find x correct to 2 decimal places in this shape, in this drawing. So I'm going to again put some numbers. So A, B, C, and D. I have 2 right triangles here. The right triangles are A, C, D. I'm gonna highlight it in yellow. And the other one is CBA. And neither of them has x as a side. However, x can be found if I do the math CB, which is one of the legs of the large right triangle, minus CD, which is a leg of the smaller right triangle. So CB is in the large triangle, and that's the triangle ABC. And in the triangle ABC, I know the angle B, that's 23 degrees. So I know this angle over here. Then CB is the adjacent. And I also know AC, that is the opposite. So I'm going to use right triangle trigonometry to solve for the adjacent. The opposite is 97. So I'm going to do tangent of 23 degrees equals opposite over the adjacent. And if you remember from the previous examples, I'm going to multiply by the adjacent and divide by the tangent of 23. The adjacent, which is CB, will be 97 divided by the tangent of 23 degrees. In the little triangle, the little right triangle, triangle ACD, they have given me the angle at D to be 51 degrees. It's right here. And then the adjacent is CD. And the opposite is AC. That is 97. And again, I'm going to use the tangent here to solve for the adjacent. So the tangent of 51 degrees will be the opposite, 97 over the adjacent CD. I'm going to multiply by CD and I'm going to divide by the tangent of 51. CD will equal to 97 divided by the tangent of 51 degrees. And they asked me for how much is x, and we said x is CB minus CD. X equals CB minus CD. And I have found expressions for those. So CB will be 97 over the tangent of 23 degrees and minus CD is 97 over the tangent of 51 degrees. This is the exact value of x. And if they want me to round, I will punch it in my calculator and round appropriately. One other problem that is in the homework 3.2 and a lot of students usually ask questions about is question 15. Question 15 says a survey team is trying to estimate the height of a mountain above a level plain. From one point on the plane, they observe that the angle of elevation to the top of the mountain is 31 degrees. From a point 2,000 feet closer to the mountain along the plane, they find that the angle of elevation is 34 degrees. How high in feet is the mountain? So we have to gain a skill, and the skill is to read something and translate it to a sketch. So surprisingly, this sketch is kind of a backward situation of the sketch from question 14. So I'm gonna draw it with the point, like the angle B on the left, but it is identical scenario, so you'll see how that looks like. But keep that question in reference when you are doing this. So we have a plane, right? We have a level plane, so it's horizontal. And we have one point on the plane. Let's call this here point. And the surveying team observes that the angle of elevation to the top of the mountain is 31 degrees. So 31 degrees here, and that is the top of the mountain. So let's assume that the mountain looks like this. This is a little abstract, but this angle is 31 degrees, and that is the top of the mountain. So let's call it T. Remember, they are asking us for the height of the mountain. So actually, they are asking us for this length. So height equals what? That's the question. So if the height is perpendicular to the level plane, this is a right triangle. So let's call it APT is a right triangle. In this right triangle, we know the angle 31 degrees. We don't know any of the sides, and we are being asked to find H. H is the opposite of the 31 degrees. Now, from a point 2,000 feet closer to the mountain, so the surveying team moves 2,000 feet closer over here. That is 2,000 feet. And from that point, let's call it B. The angle of elevation is now 34 degrees. So they look up at the mountain again, and this angle is 34 degrees. Based on this information, they are now asking us to find again the height of the mountain. And again, pay attention here that we do have two right triangles, APT and ABT. In both of those triangles, we know an angle. We are being asked to find the opposite of that angle, which is the height, but we don't know any sides of these triangles. In addition, 2,000 feet is not a side of a right triangle, but this problem is indeed the backwards of this problem. So in this problem, they gave us the height, assume the height of the mountain was the 97, and they were asking us for the little x between the 2 points. And here they are giving us the little x, and they are asking us for the height of the mountain. And again, to find the height of the mountain, we will need to use some formulas that have the opposite of the angles, 31 and 34. And the opposite appears in the tangent and appears in the sine, but the sine includes the hypotenuse, and the hypotenuse is some imaginary line here that has nothing to do with things that we can measure as humans. As humans, we can measure the height. We can also measure things on the plane. Therefore, I will choose to use the tangent function so that I can find adjacents. Now, in the triangle APT, the adjacent to the angle P is AP. And in the triangle ABT, the adjacent to the angle B is AB. And what I know is that if I subtract those two, AP minus AB, that distance is 2,000 feet. So I know that that is the fact that they have given me. So let me try to do a little bit of trigonometry and see how I can use this difference to solve for something. So in the triangle APT, the tangent of 31 degrees equals the opposite, which is the height, over the adjacent, and the adjacent is AP. And let's say AP equals, and I will multiply by AP and divide by the tangent of 31, and it will equal H divided by the tangent of 31 degrees. And in the triangle ABT, the tangent of 34 degrees is the opposite, which is the height, over the adjacent, which is AB. And from that, if I multiply by AB and divide by the tangent, AB will be H divided by the tangent of 34 degrees. So I had two unknowns actually in these expressions. I had both H and AP and both H and AB, but I solved for AP and AB because I do have an equation for those two expressions. And I have seen in previous problems that I could substitute this in to find my answer. So I'm going to use that equation to substitute the expressions. So I'm going to have AP H over the tangent of 31 minus AB H over the tangent of 34 equal to 2,000. And here I can factor the H out. I will get 1 over the tangent of 31 degrees minus 1 over the tangent of 34 degrees equal to 2,000. These are feet. And therefore I can solve for H. So H will equal to 2,000 divided by this parenthesis. 1 over the tangent of 31 degrees minus 1 over the tangent of 34 degrees. And that will be in feet. So let's see if this will work. Will that be H? All right, let's try here. So I have 2,000 divided by parenthesis 1 divided by the tangent of 31 degrees, close the tangent, minus 1 divided by the tangent of 34 degrees. And then close the denominator. So 11,006.0. How high in feet? So the height is approximately 11,006 feet. That seems like a reasonable answer.